In this video, we will see how to perform correlation, that is Pearson's correlation and Spearman correlation using Graphpad Prism 8. We will also see how to perform simple linear regression, non-linear regression, including dose response model and Michaelis-Menten model of the enzyme kinetics. Also, we'll see how to perform the multiple regression. So let us go back to our example file. So as you can see, one of the data set on the left, you can see that ozone correlation. As you see, ozone level measured against the solar radiation, wind and temperature on each day. So each row represents each day. So we have lots of data here. So as you can see, some days there is no ozone measured or solar radiation measured, but only wind and temperature data we have. Now for this, we have to perform a correlation. So how to perform the correlation? So all we have to do is analyze XY analysis correlation with all these datas. I click OK and compute X, R for X versus every Y data set. That means R is X versus A, X versus B, X versus C. Absolutely, that is what we wanted. This is a two-tailed with confidence interval 95, right? So let us click OK to see the results. So this is the result. You can see the Pearson's R is ozone versus solar radiation, ozone versus wind, and ozone versus temperature. So as you can see, the R is 0.34 for the ozone versus solar, while this is wind is negative, while temperature is positive. So what does this negative R means? So as the wind is high, the ozone level is low. Atmospheric ozone levels, as you see, it's a poisonous, it's a pollutant. It's low when the wind level is high. So that is what you expected. Absolutely fine. The temperature, as temperature increases, ozone level also increases. So this R, positive R, as you see, it doesn't mean the causation. So we will not see that is temperature is causing more ozone or more ozone is causing temperature. So that is very important while interpreting the data of the correlation here. So R is very important. The 95% is Ci and R square. So R square is also very important. So as you can see, both these R square values is very high rather than the first one, ozone versus solar. So just like the R square, the P value is also highly significant in the case of ozone versus wind or ozone versus temperature. So this is a easy way to perform the correlation of the ozone here. So ozone correlation, if you see, and another thing which I've skipped to say is that this kind of table is something called XY table. So if you click on this, you will know that it is basically XY kind. For ANOVA and t-test, we used column style of the table, but here it is basically XY table. Fine. So that is what this is how to perform the usual correlation or Pearson's correlation. We can also perform the Spearman's correlation, which is non-parametric, using the same data. Analyze correlation. I click OK. So reanalyze it. So absolutely fine. The parameter for the correlation. So we will also here, instead of the Gaussian, we will go with the non-parametric Spearman correlation with two tails. So if you click OK, so this result will be presented here. So result is quite identical to the earlier results. So the R is quite high in these two cases. This is negative R while this is positive R, and the P value is also there. Only issue with Spearman's correlation is that there is no 95% Ci. Now let us go with the second data, that is for the linear regression. So here we have the same data that we discussed in the module. Percentage C 2022 polyunsaturated fatty acids on the skeletal muscles versus insulin sensitivity. So if you have to perform, you can also do a correlation as well as a Spearman rank test, just like in the earlier one. So if you want to fit this in a linear equation, there is nothing but the linear regression. I click analyze linear regressions, or I can simply click directly this option, linear regression. So this is the easy way, linear regression. I click OK. So as you see that the linear regression will ask you many things. So we'll also do graphing the 95% confidence interval of the best fit line. So it will ask you the replicates, auto, p-value, all these are fine. I click OK. So as you see, these are the result of the linear regression. This is the equation. Best fit value is nothing but the equation. Slope is 37.21, y-intercept is minus 486.5, and 95% confidence interval is presented here, and goodness of fit is also important. R square is 0.5929, and is significantly non-zero the slope. Yes, significant because the p-value is this, but remember the p-value is not that important in the case of first the linear regression. This is the equation y equal to 37.21 x minus 486.5. So this is the data for the linear regression. So let us also inspect the linear regression, the graphical presentation of the linear regression. So this is quite fine, but we don't want this no the column graph. So instead we have to go with, let us change the graphical style by click on this, and this is to format the graph. That is not we want. We want to change the different kind of graph. So we click here. So we click the first option. So this is this will give you an idea, the preview of how the graph will look like. I click OK. So this is perfectly fine. This is XY plotter with the best fit line superimposed to it, and this curve indicates the 95% confidence interval of this. So this is a very good option to present it. So in this case there is no residual. We will also redo the same analysis with the residual as well. So this is nothing but the linear regression. Analyze linear regression once again, reanalyze it. So the output, the constraint, show 95 plus residual plot, and I click OK. So as you see that linear regression data and residual plot also you can inspect. So this indicates how good the fit is, and also the Gaussian distribution. So this is basically the residual plot is more or less about the fit. So if these residuals are more or less near this the zero, that means that it is fitting perfectly well. So if it goes further away, the fit is not that perfect. So that is what the residual plot is all about. Now let us go with the third set of the data, that is non-linear regression of log norepinephrine and percentage bladder muscle relaxation of one young rat. So we will have to do a non-linear regression. For that we click analyze. So instead of linear we'll go with non-linear regression. I click OK. So non-linear regression will also have there are several models. So which model to use? So in this case it is log agonist versus response 3 parameters. So dose response curve, I click OK. So as you see that this is what you're going to get. So non-linear regressions graph, 95% CI, goodness of fit, R square is quite high as you can see, and you can also see the fit in non-linear regression in the graphically. So as you see that this is our best fit line, which is sigmoidal, and these dots represent the scatter plot, our data point. So the fit is very good. So that is a very easy way to perform. So as you can see, the x and y axis already labeled of the non-linear regression, the dose response curve. So this is a very easy way to perform non-linear regression with the Graphpad Prism. So let us also do the non-linear regression with our third set of data, that is Michaelis-Menten data. Substrate concentration versus enzyme activity, that is in triplicate. This is nothing but the technical replicates. So we click here, then analyze non-linear regression, click OK. So here standard curve, which standard curve would you like to go with? So I will go with enzyme kinetics velocity as a function Michaelis-Menten. So this is the equation I would like to use for my non-linear regression. So this is the tabular data of the non-linear regression with Vmax and Km, very important data, and 95% CI. And the goodness of it, as you see, R square is very high. 90% of the variability is explained by X variables. So the constraints and number of points. So now let us inspect the graph of the curve fit. So as you see that this is fitting perfectly fine. with only very little bit. You can also inspect the residual plot if you choose that. So this is a concentration substrate with enzyme activity. So this is the non-linear regression of the Michelis method data. Finally, we will also see how to perform the multiple regression. So this is a multiple regression. So in this multiple regression, our main variable is glycosylated hemoglobin. You can read about this, why this is important. So now glycosylated hemoglobin is a good proxy for the diabetes mellitus. With various variables, so cholesterol, glucose, HDL, age, male or female, height in inch, weight in pounds, waist, hip inch, all those. So as you see, the table format is multiple variable. It's not simple XY, but it's multiple variable format. Cancel it here. So to perform the multiple regression, I click here Analyze, and I click Multiple Linear Regression, and go with OK. The least square is one of the options for this multiple regression. Intercept and main effect is fine. So this is the model that we are going to choose. So as you see, this is the y-intercept, or this is the baseline data, and all the different format. Check the module for explanation about all these parameters. So this is not a fit of two models, so there's no problem. So you don't really have to go with the weighting. And the diagnostics will go with all these default options, including the residual plot. So I click here OK. So as you see, this is the tabular results of different parameters. So intercept is the confidence interval is always includes a zero or our null hypothesis. So that means it is not significant. So significantly zero, it is not significant, the intercept, while cholesterol is 3 star, glucose is 4 star, while HDL is non-significant, age and years is also 2 star. So the three values are significant, the rest are non-significant, and goodness of fit R square is 58.97% is R square, so which is quite high. And multicollinearity is also given, correlation matrix is given here, and the normality of the residual, does it pass a normality test or not. You can see all these results are presented here. So let us also inspect the actual versus predicted plot of the multilinear regression. So you see that this is the actual y versus predicted y. So each value means actual versus predicted. So you see that this is the line. So how good is the fit? So fit is kind of fine, but not perfectly fine. We'll also inspect the residual plot here. So as you see that this is what, if the residual plot is more or less near the zero, that means that the fit is really good. So this is then in nutshell how to perform the multiple linear regression using Graphpad Prism software. Thanks for watching.